Welcome everybody. Pause the video and read the question carefully. The story of this equation started when we had ferrochrome. Ferrochrome is an alloy, which means it's a mixture between metals. Okay, so these metals are iron, Fe, and chromium. So the alloy that is mixed of chromium and iron is called ferrochrome. This ferrochrome is dissolved in dilute sulfuric acid. These two elements into sulfuric acid, H2SO4, you will have their sulfates like FeSO4 and chromium sulfate, Cr2SO4 by 3. And then the resulting mixture, like this and this, are reacted with chromate, which is K2Cr2O7. This ionic here is ionic, and actually it represents the reaction between the chromate Cr2O7 with iron. But you'll ask me, where did this K go? It's here as in form of Cr2O7. Put in your mind, K here works as a spectator ion, and I don't need it at all. But I just want to explain something for you. If we started before, this is the ABC in chemistry. If you have K2Cr2O7, and if you just dissolve it in water, it gives you 2K positive and Cr2O7 negative 2. So if we have a concentration as in here, 0.1 of potassium chromate, then it's going to be the same as this one here, because they are 1-to-1 mole ratio, and this one here is going to be 1. But for 2K positive, I ask you what is the concentration of K positive here. It's going to be 2 times 0.1 since it's 2-to-1 ratio. This thing should be in consideration. Okay, let's go back again to the question. The question says here, when 1 gram of ferrochrome is dissolved in dilute sulfuric acid, then the resulting mixture is titrated with this amount of potassium dichromate. The question says, what is the percentage by mass of a sample of ferrochrome? Once we say the percentage of mass of iron, it means that you have to calculate the mass of iron over the mass of ferrochrome, which is 1 gram. And then you multiply by 100. But how can I calculate the grams of iron? The mass here, in this case for iron, we just need the moles and the AR of iron, which is already given to us. So our target here is to find the moles. And now I have to go back to the equation that is in here. Can I find the moles of iron? You can say, yeah, I can find the moles of iron, but is there anything given to me? You can see that you're given the dichromate, which is Cr2O7. And actually, it's mentioned in here. Put in your mind, as we mentioned before in the equation, K2Cr2O7. Once it's dissolved in water, it gives you 2K positive, and it gives Cr2O7 negative. And since you can calculate the moles of this one here, which are C equals N over V, we can say the moles are equal to C times V. So their moles are 13.1 over 1,000. We want to change them to cubic decimeter and then multiply them by 1. It's equal to 0.00131. And these here are the same moles because they are 1-to-1. So the moles of chromate in this case are equal to 0.00131. Okay, so I have to write here 0.0031. Okay. How can I calculate the moles? It's 1-to-6 ratio, and then you have to multiply your answer by 6. Okay, so you can say the moles of iron equal to 6 times 0.00131, and the answer is 0.00786. So can I change the moles into grams? We multiply this number by the AR of iron, and then the AR of iron is equal to 55.8 times the moles, which are 0.00786. And then the grams of iron are equal to 0.4385 grams. Okay, we're asking about the percentage of iron in this case. And the mass of iron, as we can see, is equal to 0.4385. You'll divide them over 1, which is the overall grams, and then you multiply them by 100. And then the answer is going to be 43.85. So the answer is D.